I'm Emma Oakers, and today I'm going to be showing you two experiments. The first one is going to prove Charles' law correct. So for some background knowledge, Charles' law says that as temperature decreases, volume decreases. The formula we're going to use for this is V1 over T1 equals V2 over T2. So what you're going to need is a Sharpie, empty water bottle, and a measuring cup filled with 1 cup of water. So as we're pouring this in, my V1 is going to be my 1 cup of water, which we will convert to liters. Then my T1 is going to be room temperature, which is 23 degrees Celsius, which is 296 Kelvin. Now, the temperature of my freezer is 0 degrees Fahrenheit, which equals 255.3 Kelvin. So now that I've filled my water bottle up, I put a fill mark line with a Sharpie just so I can see where it is later. So now I'm going to put it in my freezer. Okay, so in 2 hours I'll be back and show y'all what happened. Time to grab my water bottle out of the freezer. As you can tell, the gas inside the water bottle shrunk, which squished the water because of the decrease in temperature. This proved Charles' law to be correct. A review of Charles' law. Charles' law states that as the temperature decreases, volume decreases. The formula for Charles' law is V1 over T1 equals V2 over T2. Volume 1 is the 1 cup of water I used. I converted this to liters. T1 is the temperature of the room, which I converted to Kelvin. V2 is what I was looking for, so I labeled it as X, and T2 is the temperature of the freezer, which I also changed to Kelvin. This was my work, and as you can see, for V2, I got an answer of 0.204 liters. Charles' law in conclusion. The volume before was 0.237 liters, after was 0.204 liters. I subtracted and got 0.033 liters. The temperature decreased by 40.7 K, and the volume decreased by 0.033 liters. This is how I will find the percent error. Using the numbers before, this is how I calculated percent error. Okay, so for the next law, I'm doing Boyle's law, which states when pressure increases, volume decreases. The formula for this is P1V1 equals P2V2. Okay, for my experiment for Boyle's law, what you'll need is a syringe and 1 mini marshmallow. So what you want to do is put this mini marshmallow at the bottom of the syringe just like this. Now, you're going to put the syringe topper on, and you're going to slide it just to 10 millimeters to start with. Now what you're going to do is you're going to put your thumb over the opening, and you're going to compress this topper all the way down to 5 milliliters. Now as you can see, the farther down you go, all the way down to 5 millimeters, the smaller and the more shrunk that the marshmallow gets. Now, to show you the opposite, when I release back to 10 milliliters, the marshmallow gets its regular size. Now, what this shows is that when pressure increases, volume decreases. So let me show you again. As I go down to the 5 milliliters rather than the 10, the marshmallow gets shriveled up and it shrinks in size, just like this. And whenever I release back to 10 millimeters, the marshmallow goes back to normal. Boyle's law. Boyle's law states that when pressure increases, volume decreases. The formula for Boyle's law is P1V1 equals P2V2. My work. P1 is just the pressure of the kitchen, which is 1 atmosphere. V2 is what I started the syringe at, which was just 10 millimeters. Then P2 is what I was looking for, so I labeled it as X. And then V2 is what I pushed the syringe stopper down to. As you can see, I plugged in all my numbers from the formula above, and I got 2 atmosphere, which is what P2 equals.